Section 5.2, large prime numbers. For a list of the first 10,000 primes, visit primes.utm.edu. Lists small 10,000. So primes less than 10,000 are considered to be small. Mersenne lived from 1588 to 1648, and he studied integers of the form m sub n equals 2 to the n minus 1, and proved that if n is composite, then m sub n is also composite. Example, m sub 4 equals 2 to the 4th minus 1, which is 16 minus 1, which equals 15. 15 is 3 times 5. It is a composite number. 4 is 2 times 2, a composite number. So if n is composite, then m sub n is also composite. Leads us to ask the question, if n is prime, is m sub n prime? Remember, m sub n equals 2 to the n minus 1. M sub 2 equals 2 to the 2nd minus 1, which equals 4 minus 1, which is 3. M sub 3, 2 to the 3rd minus 1, which equals 8 minus 1, which equals 7. M sub 5 is 2 to the 5th minus 1, which equals 32 minus 1, which equals 31. M sub 7 is 2 to the 7th minus 1, which equals 128 minus 1, which is 127. The Mersenne number m sub 11 equals 2 to the 11th minus 1, which equals 2047. 2047 is 23 times 89. M sub 11 is composite. Answering our question, if n is prime, is m sub n prime? The answer is, if n is prime, m sub n may be either prime or composite. By 1600, it was known that m sub n is prime for all prime n up to 19. A Mersenne number m sub n that is prime is called a Mersenne prime. The Mersenne prime m sub 31 was discovered by Euler around 1760, the same Euler who we used for the Euler diagrams. The Mersenne prime M127 was discovered by Edward Lucas in 1876. In 1952, an early computer found Mersenne primes for n equals 521, 607, 1,279, 2,203, and 2,281. Yes, a computer in 1952. In 1996, the great internet Mersenne prime search, GIMPS, was launched. GIMPS currently involves about 1 million CPUs worldwide. You can download a program. It runs in the back of your computer and searches for the next prime number. As of today, 51 Mersenne primes are known. The largest one is more than 1.5 million digits long. Section 5.2, large prime numbers.